Alright, section 8.6, solving radical equations. So, a radical equation, very similar to a rational equation. Rationals have to have a rational in them, a radical has to have a radical in them. So you've got three examples here. Whether it's a cubic or a square or a to the fourth, whatever, they just need to have at least one. They don't need to have it on both sides, but they can. And it's an equation. So all of our all of our radical expression rules still apply. They just apply to both sides. Again, just like rationals, we also have extraneous solutions. So there are certain answers that when we're solving for make sense in the equation we've created, but don't make sense because you end up getting something like a negative under the radical, or you end up getting, basically that's the one that doesn't work, or negative under the radical, or because we're squaring to both sides, it doesn't end up being true, is basically what we're trying to say here. The new power rule we're going to use is called the power property of equality. It's very, very similar to addition and subtraction and multiplication and division. It says you can take a power to both sides, and it's not going to change the original equation. It's not going to change the equality of the equation. You just have to double check for extraneous solutions. So let's go ahead and try a few of these out. Alright. I have the square root of this whole thing, 3x plus 4, is equal to 8. Excuse me. I'm going to start with the power of equality rule, the power rule of equality, which says I can take the square of both sides, I can take any power to both sides and not change the equality. So remember our nth power rule? If I have the square root squared, that goes away. They cancel, right? That's the nth power rule. So like if it's of 2, that just becomes 2. Same thing goes for the cubed root, right? I can cube it. Oops. And it just goes away, right? Those two things cancel each other out. So even if I don't know what is the radicand, I don't know what's sitting under there, I don't know x is what I'm trying to say, I can get rid of that square root by squaring both sides. So here's my original equation. I can square root, and it cancels out. And what I'm left with is just exactly what is written under the radical, 3x plus 4. Now, what I do to one side, I must do the other. That's what the power rule says. It will change it if I don't do it to the other side as well. So that becomes 8 squared, or 64. Now it's just a linear equation and I can solve. So subtract 4 from both sides. End up getting 3x is equal to 60. Divide by 3. You end up getting x, is equal to 20. So I know x is equal to 20. Now, actually, before I go boxing that, I want to make sure that that doesn't cause a problem under here. So if I put in 20, am I going to get like a negative number? Okay, so let's see if that's actually true. 20 times 3 is 60, plus 4. Square root of 64 is, in fact, 8. Okay, that is a good solution, right? That's a good solution. So you do have to check your answer for extraneous solutions. Let's try it again. Now, even though we have a new property of equality, right, a new countering tool is sometimes as they've been called, it still goes the same way. So when you're solving an equation, you want to start as far away from the variable as possible, right? Get your variable on one side, and then start as far away from possible on that side. So the farthest thing away is this 3. I'm going to deal with the 3 first. I don't want to take the square root of both sides before the entire side is being square rooted. After that, it just gets complicated. So I'm going to subtract this 3 to both sides. I end up getting the square root of 5q minus 1, right? That's what's left, not p, sorry. 5q minus 1, because those 3's cancel, is equal to negative 3. It's equal to negative 3. Okay, so let's take the square of both sides now. Square it, right? You end up getting 5q minus 1 is equal to 9, right? 5q minus 1 is equal to 9. Add 1 to both sides. You get 5q is equal to 10, or q is equal to 2. Now, before I go boxing, I want to make sure that actually makes sense, right? So I plug that in. 5 times 2 is 10, minus 1 is 9, right? So 5 times 2 is 10, right? 5 times 2 is 10, minus 1 is 9, so I have the square root of 9 plus 3 equals 0. Hey, wait a minute. Does 3 plus 3 equal 0? That's not true. That is an extraneous solution. That can't be true, right? And here's the reason why. When we subtracted this over to the other side, we got that the square root of something equals a negative number. The square root of something equaled a negative number? That's impossible. You can't have the square root being negative, right? That doesn't make any sense. Nothing would have ever given us a negative 3 when we take the square root. So that's how we found this extraneous solution. We kind of use the idea that no matter what we square, we'll end up being positive. And that's where it's kind of like, not really, sorry dude. So this one actually has no solution. No real solution. No real solution. Alright, so hopefully that extraneous solution thing made sense. Let's continue on. I have x's on both sides now. That could be a problem, right? However, let's see, I've got this entire side being squared, so I'm actually going to start by taking that to the power of 2. X plus 2. What I do to one side, I must do to the other as well. So I'll take the square of both sides. I'm left with 4 minus x here. And then remember, this is not going to be x squared plus 4. It's going to be x plus 2 times x plus 2. So we end up getting 4 minus x is equal to x squared plus 2x. 2x is 4x plus 4. If that was confusing to you, then you need to go back to the chapter 5 videos. I want to say chapter 5.3-ish, around there, on multiplying binomials. Okay, special cases, look out for that. Now I have a quadratic, so I'm going to need to factor. Let me subtract 4 and add x to both sides. I end up getting 0 is equal to x squared plus 5x. Let's do this one at a time, hold on. So minus 4, those cancel out, right? They cancel out on both sides. Minus x, so add x, you end up getting 0 is equal to x squared plus 5x. Sweet, I don't have to do general trinomials because I see a GCF there, x plus 5. So in this case, either x is 0 or x is negative 5. But before I go boxing either one of those, I want to check that they don't cause a problem. The only place they'd cause a problem is on this left-hand side. So 4 minus 0, that's going to be a positive 4, right? You can take the square root of a positive. All right, 0 is good. Check. Check, 0 is good. 4 minus 5, So 4 minus negative 5, that's going to be a positive 9, and that is also okay. So that would be, check, that would be okay. That would be okay. Because x would be negative, right? Alrighty. Let's do another one. This time we've got two radicals. I'm going to start by, I think even though this is not entirely by itself, I'm still going to square both sides. So let's square both sides. Because I can square a 2 pretty easily. So 2 becomes 4, right? So they're being multiplied, I can distribute. And that's 4x equals 3x plus 4. Because those two cancel. Subtract, subtract. I get x is equal to 4. Oops. Before I box, I double check that I don't have an extraneous solution. Let's see. Square root of 4 on that side would be a 2. That's okay. That's okay. Square root of 4 on the right-hand side, let's see. 4 times 2 is 12, plus 4 is 16. That is also a positive number. So x can definitely equal 4. That's okay. In fact, I should have boxed those as well. All right. Hopefully this extraneous solution, that's the new part. That's really the part you've probably never seen before. That's the part you have to double check, okay? Only when you end up with negatives on one side and roots on the other should you ever be worried. Other than that, they really don't pop up. So let's keep trying. These take some additional steps, quote unquote, but they're really the same thing. Okay, I've got this polynomial on one side that is all being square rooted. So let's start with that. Square both sides. That cancels. I'm left with x squared minus 4x plus 9 is equal to x plus 1 squared is the same thing as x plus 1 times x plus 1. X x plus 1 times x plus 1. Alrighty. I still have 4x minus x squared minus 4x plus 9. Multiply that out, you get x squared, 1x and 1x is 2x, times 1 is 1. You might be thinking, oh crap, double quadratic. That's actually a gift for you, because then if you subtract those to two sides, they cancel out. You're left with two linears. So negative 4x plus 9 is equal to 2x plus 1. Now it's just linear. That's nice. If you end up with a double quadratic, that's a gift. That's not that's not a curse. Alright, so then we'll go, let's see, let's add, I think I'm going to add 4x to both sides. Because, you know, why not? I end up with 9 is equal to 6x plus 1. Subtract the 1. You end up with 8 is equal to 6x. Or in other words, 8/6 or 4/3 is equal to x. 4/3 is equal to x. Alright, now before I go boxing anything, I gotta go double check that's not gonna be a problem. On the right hand side, all positive. Doesn't matter. There's not even a radical on the right hand side. I don't need to worry about that. Let's see, is that going to equal 0? So let's plug it in and find out. X squared minus 4x plus 9. Hopefully that does not equal a negative number when I plug in 4/3. So let's try that. 4/3 squared minus 4 times 4/3 plus 9. Well, 4/3 squared is 16/9, right? It's true to poverty. That's going to be 8/3 plus 9. Common base, 16 over 9 minus, let's see, times 3 times 3, 24 over 9. 9 whole numbers would be 27 over 3. So I get 16 minus 24 plus 7. Sorry, plus 27. Positive 19/3. Sorry. I don't want ninths. I don't want thirds, I want ninths. So not 27. That would be 81/9. (81) plus 26 minus 16. No. 16 minus 24 plus 81, sorry about that, would be 73/9. 73/9. And that's a positive number, so totally fine, right? Totally fine. Excuse me. As long as it's positive, that's not going to cause a problem underneath this radical. So that would be, so x equals 4/3 would be a fine solution. That would not be extraneous. Alright, let's keep going. Excuse me. Okay. Again, I've got an entire side being square rooted, so I can square it. Square both sides. I get a squared is equal to a squared plus 3a plus 9. Again, quadratic on both sides is a gift. I end up with 0 is equal to 3a plus 9. Negative 9 is equal to 3a, right? Subtract the 9 over, move it over. Now you may be thinking, oh my gosh, I got a negative, but careful. We don't have a negative and a square root together, right? So this shouldn't cause much of a problem. A is equal to negative 3. And then we'll double check that solution. Let's double check it on the left-hand side first. Can I have negative 3 equal to the square root of negative 3 squared plus 3 times negative 3 plus 9? I already see a problem. I have a negative 3 as the answer to a square root problem. That doesn't make any sense. That doesn't make any sense. So right here, where we squared both sides, the very first step, we made a boo-boo. This is an extraneous solution. There is no real solution. Bummer, right? Bummer. Oh well. Let's try a couple more. Alright, for this next one, we have root 5x plus 6 plus square root of 3x plus 4 equals 2. So now we've got two separate radicals on one side. These ones are probably the trickiest because we're gonna have to square things individually. Okay, so we're gonna have to square things individually. I can't just square the whole side willy-nilly, because remember they're being added. If it's adding or subtracting, you can't just square both of them, right? That's the same property as distribution. You cannot distribute a square. So what I'm going to do instead is I'm actually going to need quite a bit of room for this, so I'm going to start up here. I'm going to take the 5x plus 6, I'm going to keep it there, but I'm going to move this guy over to the other side. It's going to equal 2 minus square root of 3x plus 4. Okay. Now I'm going to square both sides, and I'm going to square both sides like so. Square both sides. Square. Page. Okay. Square both sides. Alright. When I square this first side, I just end up with 5x plus 6, right? The left-hand side is just cancel. This side, though, I have to square the whole thing. Notice I put the parentheses around everything and not just the squared part. I'm going to do that up here, kind of on the last page, to be honest, and save myself some room. So 3x plus 4. Remember, that means times itself. So it's not going to be 4 minus 3x plus 4, right? It's going to be 2 minus 3x square root of 3x plus 4 times itself. Piece by piece. 2 times 2, that's 4. 2 times negative root 3x plus 4, it's going to be negative 2, 3x plus 4, root 3 plus 4. Same thing when I go the other way, so minus 2, root 3x plus 4. And then lastly, I have root 3x times itself, so I get a positive 3x plus 4. The radical goes away. Now I can combine some stuff. I have 4 minus, these two guys combine together to 4 root 3x plus 4, right? Because they are the exact same radical, so I can combine their coefficients. And then I have a plus 3x plus 4. So one more thing I can combine is those 4's, and what I end up getting on this side is 8 plus 3x minus 4 root 3x plus 4. You may be thinking, how on earth did that help us? I ended up with more terms and more radicals, right? But it did. I got rid of this radical on the left-hand side. Like I said, we're going to get rid of each radical separately. So I got rid of the radical on the left-hand side. Now let's move some of these other coefficients over. So move some of those other coefficients over to the other side. So minus a 3x from a 5x gives us a 2x. Minus an 8 from a 6 gives us a negative 2. And now we're just left with negative 4 root 3x plus 4 on the other side. Okay, so that we got rid of the first one. We got rid of the first one, we reduced it back. So now we only have one radical left. Let's go ahead and, well, I've got a lot of 2's going on here. I'm going to divide everything by 2. Just to make my life a little easier. I'm going to write a little smaller. Sorry. Divide everything by 2. I end up getting x minus 1 is equal to negative 2 root 3x plus 4. That way, when I take the square of both sides to get rid of that radical, it's easier to square x minus 1 than it is 2x minus 2. So now I'm going to square both sides, and I'm going to go ahead and do that down here. Oops, that's not the button I wanted to press. That is the button I wanted to press. So now I'm going to square this side. So these two will cancel. So I'm going to distribute this guy in. Right, this is being multiplied, right? This is being multiplied. That's why I wanted this to happen. So instead of this guy where it's being subtracted, I can actually distribute that 2 in. Over here I get, let's see, x minus 1 squared is the same thing as x minus 1 times x minus 1. That's going to be equal to negative 2 squared times the square root of 3x plus 4 squared. Right? So that's what I have going on here. This squared ends up being x squared minus 1 minus, or minus x is minus 2x plus 1. Negative 2 squared is 4. And that's going to be times 3x plus 4. Because that's what happens when you square a radical. Excuse me. Let's simplify that right-hand side a little bit. X squared minus 2x plus 1 is equal to 12x plus 16. So we kind of went from here to here. Now we went here to here. We're going over here. Let's write that in red. Let's see, if I subtract the 12 and subtract the 16, I end up with x squared. 12 minus, that would be negative 14. X. 16, so 1 minus 16 would be negative 15 equals 0. Now I got to factor what two numbers multiply to negative 15 and add to negative 14. That would probably be negative 15 and 1. So this will factor to x plus 1, x minus 15 is equal to 0. Okay, so either x by zero product property, x is equal to negative 1, or x is equal to positive 15. Those are my two proposed solutions. Those are my two maybe answers, but we got to check that they'd actually work. So negative 1 under the radical here. Let's check this one. Negative 1 times 5, negative 5 plus 6. That would be a square root of 1. Okay, so far so good. We'll check the other one. Negative 1 times 3 plus, so that would be negative 3 plus 4 would be a positive 1 under the radical. Okay, looks like that one works. Check. We can check that one off as it works. We can actually put a box around it. 15, let's try that. Well, let's actually plug this one into the equation. So the original equation, we have 15 times 5 plus 6, which is square root of 81. So square root of 81 when we plug in 15. Over here we've got plus the square, so 3 times 15 plus 4, that's going to be 49. So square root of 49 equals 2. I don't know, this is sounding a little weird. 9 plus 7 equals 2. I can tell you 9 minus 7 equals 2. So that number was dependent on the fact that it was a negative 7. And since it's not a negative 7, this doesn't work, right? It doesn't work. So that doesn't look like our solution. Bummer. Oh well. X equals negative 1 works though. Fabulous. Well, we can double check that too. So square root of 1 plus square root of 1 equals 1 plus 1, which is 2. Check. That one works. Alright, so you got to double check them every single time because all that work could be for nothing, right? All that work could be for no solution. But this one, we actually did have one real solution. Let's try another one of those. The same kind of dealio. And this time, let's see. Yeah, we'll do the same thing. Yeah, well, yeah, it's fine. We'll do the same thing. Okay, so I'm gonna move this guy to the other side. I have square root of 4x plus 5 is equal to 1 plus root 2x plus 2. This time it's a plus because I moved it over to the other side by adding it to both sides. Square both sides, you get 4x plus 5 is equal to, let's see, if I'm squaring this, that's that times itself. So 1 times 1 would be 1 plus 2 of those, 2 root 2x plus 2, and that times itself would be plus 2x plus 2, right? And if that was a little confusing, go ahead and check out what I did up here. It matches almost exactly. Okay, and then we can simplify some things. When we get to the other side, I can move the 1 and the 2 to the other side. That's a 3, so this becomes a 2. I've got 2x, so this is 2x is equal to 2 root 2x plus 2. So that becomes a 3, right? That becomes a 3. Subtract that from 5, you get a 2. I've got the 2x, you subtract from the 4x, you get 2x left over. Let's square both sides. Square and square. Actually, I take that back. I'm going to divide by 2 first. Divide by 2 just because I've got 2, 2, and 2. I see lots of 2's here. So I end up getting x plus 1 is equal to the square root of 2x plus 2. That makes my life heck easier. So now I've got x plus 1 is equal to squared is equal to 2x plus 2 when you square both sides, right? That was so easy. X plus 1 squared ends up being x squared plus, well, I don't want to write it there, just in case I need to double check some answers. Let's go over here. Let's go over here. So x squared plus 2x plus 1 is what x plus 1 squared is. Again, check out chapter 5 if you forgot how to do that. That still equals 2x plus 2. Subtract, subtract. Get x squared minus 1 equals 0. Ooh, special case, yay. X plus 1 equals 0. Oops, getting ahead of myself. X minus 1 equals 0. Now zero product property says x can equal negative 1 or x can equal 1. Before I go boxing those, let's double check that. So let's double check that those actually work. So square root of 4 times 1 is 4 plus 5 is 9. Minus, not plus. 2 times 1 is 2 plus 2 is 4. That should equal 1. So I have 3 minus 2 equaling 1. Check. That means when I plug in a positive 1, I'm good. So that is definitely an answer. Let's try a negative 1. Square root. Oops. 4 times negative 1 is negative 4. Plus 5 is negative, so negative 4 plus 5 is 1. Minus negative 2 plus 2 is 0. That should equal 1. That's 1 minus 0. That does equal 1. Check. They both work. Fabulous. They both work. Awesome. So these ones aren't, they require additional steps, hence why they're under the section radical equations that require additional steps. But they are steps you guys know. You know how to factor. You know how to take squares of both sides. You know how to multiply squares of polynomials, right? Or binomials. So it's just steps that you need to, mess around with. See what steps you can get so that you can get all of the radicals away and then solve using maybe factoring or just linear equations. That's fine as well. Alright. The next thing we're going to talk about is higher powers. Same thing though. The rule applies to both squares and higher powers. So we don't need to worry about anything changing. If I have a cube on both sides, I can just take the cubes of both sides, right? So I get z plus 5 is equal to 2z minus 6. Oops. Not z plus z, Miss K. Z plus 5. Those two cancel. Cube cancels the cube root. In this case, that plays out well on both sides, and I end up getting just that, a linear. I can subtract z, add 6, add 6. I end up getting 11 is equal to z. Before I go boxing that, let's check for extraneous solutions. Check for extraneous solutions. So, cubed root of 11 plus 5, what would that be? The cubed root of 16, right? Cubed root of 2 times 11 minus 5, that would be 22 minus 5. Okay, what did I do? Oh, 2x minus 6, sorry. That's 2z minus 6, not 2z minus 5. Is equal to 22 minus 6, or the cubed root of 16. So notice I didn't even actually have to get it down to a whole number, but I proved that they are equal to each other. And so this is a good solution, not extraneous. Check. Fabulous. Once again, I have in this 4th degree equation, I don't have to worry about those additional steps because everything's being taken to the 4th root. So I can take everything to the 4th power and everything to the 4th power. And getting a plus 8 is equal to 2a. Subtract, I get a is equal to 8. Double check that. Square root of 8 plus 8, that's equal to 0, square root of 0 or 0. The 4th root. Hold on. Sorry, Miss Case just had a brain fart there for a sec. The 4th root of 8 plus 8 is not 0. It's the fourth root of 16, which is 2. Fourth root of 16 is 2. And then the fourth root of 2 times 8, well, again, that's the fourth root of 16, and again, 2. So they are still indeed equal to each other. All right, cool. That works. So no extraneous solutions. This is a good solution. Check. Last thing we're going to talk about today is formulas. Formulas with square roots and solving them. As you can see, again, very popular subject, being able to use these formulas, rearranging them. And once again, rearranging has to follow all the same rules that solving does. Has to follow all the same rules solving does. So we just have to start solving for c. We pretend that c in this equation, z equals the square root of L over c, is the same thing as if z and L were numbers, right? We're just solving for c. So I'll start by squaring both sides. Squaring both sides. I get z squared is equal to L over c, right? And then I can, let's see, I want c by itself, so I can times by c so that it goes up into the numerator. Remember those rational tricks? So cancel those, you get c z squared is equal to L, and then divide by z squared. So you get c is equal to L over z squared. Awesome. Let's do the same thing over here. I want to solve this one for L. F equals 1 over 2 pi square root LC. For L, this is actually a physics spring equation, I believe. It's like a interval notation. Spring interval, you might see this if you're going into engineering a lot. Let's start by taking this rational away. We'll take the rational away. I'm just going to rewrite it. So I have F is equal to 1 over 2 pi square root LC. I'm going to multiply by the denominator, 2 pi square root LC, 2 pi square root LC. Those two will cancel. I'm left with 2 pi square root LC is F is equal to 1. Now I'll divide by everything that's not LC, right? Because I want to get L by itself. So I'll divide by 2 pi F, divide by 2 pi F, and I'm getting the square root of LC is equal to 1 over 2 pi F. Now I can square both sides. Once the radical is all by itself, I can square both sides. I get LC is equal to 1 over 4 pi squared F squared. And then I can divide by C. And I end up getting L is equal to 1 over 4 pi squared F squared, and then just a lonely C. He didn't get to get squared. And there is my solution solving for L. Alright, hopefully that answered some of your questions. If not, then shoot me an email. And otherwise, I will see you in the next video.